Okay, so homework 6, the last one before our exam. What I tried to do on this worksheet, why I made it myself instead of just using the book, is I wanted to kind of throw at you every possible way K-maps can come. That way you're totally prepared. So let's start with the first one. Notice the first thing we need to do is ask, does it need to be De Morganed? And in this case, no. Notice that their overbars at most extend over one character. Next question, is it in sum of products? It is. Third question, is it in standard sum of products? And notice that it is. All of the terms have all of the letters. And so all we need to do is figure out where would this thing be true. Well, it's going to be true at 0, 0, 0, 0, at 0, 0, 0, 1, at 1, 1, 1, 1, and at 1, 1, 1, 0. And so since this has 4 letters, A, B, C, D, we're going to need to use the K-map that has 16 cells. By the way, for this whole homework, I already drew them, or this video would take hours. So let's go ahead and enter it in. So we've got 4 zeros. That's here. I've got 0, 0, 0, 1. So again, 0, 0, 0, 1 is going to be here. We've got 1, 1, 1, 1, which is here. And we've got 1, 1, 1, 0, which is here. So we're done filling it out. Next thing we need to do is group our ones. So remember, we want the biggest groups we can make. It has to be powers of 2. We have to make sure we include all the ones, but if a 1 is in more than one group, that's fine. Wraparound is okay, and it must be perfect squares or rectangles. So it looks like there's not much choice here, right? We've got a group of 2 here, and we've got a group of 2 here. Next thing I want to do is indicate my regions. So this is the A region, because A is always 1 there. These 2 rows are the B region, because B is always 1 here. These 2 columns are the C region, because C is always 1 here. And the middle 2 columns are the D region, because D is always 1 there. I'm going to start with the one in the upper left. Notice that it is entirely outside of A, meaning these 2 cells, no part of them is in these 2 rows here. So we put an overbar. It's also entirely outside of B. It's also entirely outside of C. And notice that while this one is inside of D, this one is outside of D. And so it crosses D, we can't draw any conclusions. Or, now we're going to go to this group. Notice that all of it is inside of A. All of it is inside of B. All of it is inside of C. And it too has part in D and out of D. And so this is as simple as this circuit can be made. Basically, if I were told I need to build this, I could build this and it would do the exact same thing. Which is a big deal, because notice we're getting rid of a whole term. We no longer need that input D. Alright, next one. First question, just like before, is it in sum of products? The answer here, actually the first question is De Morgan, but it does not need to be De Morgan. Is it in sum of products? No, it's not. Right, remember, we need to distribute this because it's not yet in sum of products. So let's do that first. That's going to give me A naught, B, C naught, D naught, or A naught, B, C naught, D. So I just multiplied that times that, and that times that. Over here, A, B, C naught, D naught, or A, B, C naught, D. And then finally we have A, B naught, C naught, D. Next question, is it in standard form? And it looks like it is, right? All of the terms have all of the numbers, all of the letters rather. So we just need to figure out, where is this thing going to be true? Well, it's going to be true at 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, and 1, 0, 0, 1. Alright, now we just need to fill out the K-map. So let me bring it up. I gave myself more room than I needed in this one. Alright, so we need a 1 at 0, 1, 0, 1. So where is 0, 1, 0, 1? 0, 1, 0, 0. 0, 1, 0, 0 is here. 0, 1, 0, 1. So 0, 1, 0, 1 is here. 1, 1, 0, 0. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 0, 1. And finally 1, 0, 0, 1. So that's 1, 0, 0, 1. Alright, so we have all of our ones in place. Now we just need the group. So the biggest group I can make, I think, is pretty easy to see. It's these four right here. After that, we still have one left. Not much I can do. Best I can do is make this a group of 2. Finally, let's identify our regions. Always the same. A, B, C, D. And finally, let's write our equation. So I'll start with the blue one first. Notice that half of it in A, half of it's out of A, so we don't write A. It's all inside of B. It's all outside of C. And it's half in and half out of D, so we don't write D. Or, the red one will do now. All of it is in A. It's half in, right? This is in B, this is out of B, so we don't write B. It's completely outside of C, because both of these are outside of this region here. Remember, this is all C here. And it's entirely inside of D. Both of them are inside of D. So that's it. That's the second one. Try the third one. Give myself a little bit more room until I'm sure I don't need it. So again, is it in sum of products? It's not, so we need to distribute. So remember, this times this, this times this, then this times this, and this times this. So that's A naught, B naught, C, D, or A naught, B naught, C, D naught, or A, B naught, C, D, or A, B naught, C, D naught. Okay? Now it's in sum of products and it's in standard sum of products. So we can go straight to finding out where this equation is true. Or this circuit is true, rather. It's true at 0, 0, 1, 1, at 0, 0, 1, 0, at 1, 0, 1, 1, at 1, 0, 1, 0. So those are the locations it's true. Bring this back up and let's fill it out. So I've got a 1 at 0, 0, 1, 1. So 0, 0 row, 1, 1 column. 0, 0, 1, 0. That's here. 1, 0, 1, 1. So 1, 0, 1, 1 is here. And 1, 0, 1, 0. So 1, 0, 1, 0. Ooh, this is a nice one. So again, we do our groups. Looks like we only need, how many groups? 2 groups or 1 group? If you said 1 group of 4, you would be correct. So that's our group. Again, we've got A, B, C, and D. And so let's write our equation for the red box. It's half in, half out of A, so we don't write it. It is entirely outside of the B region. It is entirely inside of the C region, and it crosses D. So that entire equation, that entire big circuit could be broken down to this. And again, look, we had one AND gate that connects these two. We had 2 different OR gates for each of the inside stuff, and we had a whole bunch of inverters. And we can replace all of that with just one AND gate, one inverter with only B and C. Alright, let's try D. So in this case, is it in sum of products form? And the answer is yeah, it's already in sum of products form. However, it's not standard. Notice that we don't have all 4 variables in each of the AND gates. So let me write this out to give myself a little bit more room before we do this. We have A naught, B naught, missing C and D. We have A, B naught, missing C and D. We have C, we're missing, rather, A and B, but we have C naught and D naught. And in the last one, we're missing A and B, and we have C and D naught. Okay, so if we're missing two variables, how many combinations are there? Did you say 4? Come on, by now we gotta know this equation, right? So for all 4, A and B have to be 0. And then these can be any possible value. So all the way 0, 0 through 1, 1. Over here, missing 2, so we've got 4 rows. All of them have to start with 1, 0. But then we could have anything from 0, 0 to 1, 1. Over here, same thing. 4 rows, all of them have to end in 0, 0. But the first two could be 0, 0, 0, 1, 1, 0, or 1, 1. And same thing here. All 4 have to end in 1, 0, and we can have any sort of combination otherwise. Okay, now we just need to fill it out. So we have one at 0, 0, 0, 0, done. One at 0, 0, 0, 1. One at 0, 0, 1, 0. And one at 0, 0, 1, 1. We have one at 1, 0, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. And 1, 0, 1, 1. We have one at all zeros, which we already have. 0, 1, 0, 0, which is here. 1, 0, 0, 0, which we already have. And 1, 1, 0, 0, which is here. We have one at 0, 0, 1, 0, which we've already indicated. 0, 1, 1, 0, which is here. 1, 0, 1, 0, which we've already indicated. And 1, 1, 1, 0, which is here. Oh, look at this one. Look at this. Does this get you excited? What can we do here? See, I'm trying to give you all the trickiest ones I can give you. What do you think? 4 groups of 4? Nah, come on, we can do better than that, right? How about 2 groups of 8? So connect those up there with these down here, because remember, it wraps around. And I'm going to connect these 4. Let me do a different color so I can write it out. And these 4 here with the 4 over here. See, this isn't hard. It's like a puzzle. It's kind of fun, right? I've got my A region, my B region, my C region, and my D region. Alright, let's do the blue group first. So notice it's half in, half out of A, so we don't write it. It is half in, half out of B, so we don't write it. The blue group crosses C, because this is in C, but this is not in C, so we don't write it, but is entirely outside of D. So all we write is D naught. Or, now let's do the red group. Red group is half in, half out of A. It's entirely outside of B. Remember, this is B here, and the red group is outside of that. It crosses C and it crosses D. So that right there is all we need. That whole equation can be simplified to just this one OR gate. Pretty nice. Alright, the last one. So again, already in sum of products, it's not in standard form yet, right? Because we have A, but that's missing B, C, and D. This one's missing A. We have B, C naught, and it's missing D. And this one here is missing A and B, but we have C and D. So I think I'm going to need a little bit more room. So in the first case, we are missing 3 variables, which means there's 8 combinations that are missing. For all 8, A has to be a 1. A little bit more room. And then remember, these are going to be every other possible combination. So it's just like filling out a truth table. By the way, if this is the first time you're seeing this shortcut way for how to count or fill out a truth table, go back and watch, not the last homework, but the one before that. The one we covered truth tables and stuff. I think I showed you how to do that on there. Or you can just count. Either way works. In this one, we're missing 2 variables. So that means we're going to have 4 rows. 0, 0, 1, 1, 0. I'm trying to do each one different so I can keep you confused. Not really. I'm trying to do it each different, so no matter how you do it, you understand what's going on. 0, 0, 1, 1, 0, 1, 0, 1. There we go. Fill out our K-map. So 1, 0, 0, 0, that's here. 1, 0, 0, 1, that's here. 1, 0, 1, 0, that's here. 1, 0, 1, 1, 1, 0, 1, 1. Can you tell we're just going to fill out the whole 1, 0, 1, 1, that's here. Can you tell we're just going to fill out the whole A range? Because as long as A is true, it's true. 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. Alright, next up is 0, 1, 0, 0, that's here. 0, 1, 0, 1, that's here. 1, 1, 0, 0, which we already have, and 1, 1, 0, 1, which we already have. 0, 0, 1, 1, that's here. 0, 1, 1, 1, that's here. 1, 0, we already have. And 1, 1, 1, 1, we already have. Alright, it's kind of ugly, I get it. Yeah, it's kind of ugly. Alright, what type of groups can we make? Well, like I said, always start with the biggest group you can make first. So our biggest group is pretty easy to see, right? It's this group of 8 down here. Alright, next biggest group, that's kind of how I would do it. We got a group of 4 we can do here. And then what's the next biggest group we can make? Well, we can do another group of 4, right? These 4 right here. And now we've included everybody. Nobody gets left out. Alright, so I've got my A range, I've got my B range, got my C, I've got my D. Alright, so we'll do the blue group first. It's entirely inside of A. It crosses B, it crosses C, and it crosses D. Done. Let's do the red up and down next. So it crosses A, it crosses B, but it is inside of C and inside of D. And finally, the last group, the 4 that are in white, it crosses A, it is entirely inside of B, it is entirely outside of C, and it crosses D. So, wait, yeah, that's it. And look what you know. It's the same thing we started with. This one couldn't be simplified. It was already as simple as you can make it. And sometimes that happens. Alright, so, the truth table ones. Now, honestly, these are easier. I hope they didn't confuse you, but notice, basically, we just have to fill out where their ones are. So, this is a 3 variable, so it's the smaller one. So, it looks like we have a 1 here, right? We have a 1 at 0, 0, 1. That's here. We have a 1 at, well, remember, we don't write the zeros. We have a 1 at 0, 1, 1. So 0, 1, 1 is here. We have a 1 at 1, 0, 0, which is here. We have a 1 at 1, 0, 1, which is here. And we have a 1 at 1, 1, 1. Where's 1, 1, 1? Oh, that's here. Alright, what do you see? Do you see it? I see it. We have, first start with your biggest group, so group of 4 here. What about the others? Group of 2? No, you didn't say group of 2, did you? You said a group of 4. Look at that. Group of 4. Alright, so our A range, our B range, our C range. Alright, so let's do the blue one first. It crosses A, it crosses B, and it's entirely inside of C. And then we've got the red one. So the red group is half in, half out of A. It's entirely outside of A, and it crosses C. So this is it. Next up. Alright, so we've got a 1 at 0, 0, 0, 1. So 0, 0, 0, 1. At 0, 0, 1, 0. 0, 0, 1, 0. At 0, 1, 1, 0. 0, 1, 1, 0. At 0, 1, 1, 1. 0, 1, 1, 1. At 1, 0, 0, 0. at 1010, at 1100, at 1101, and at all ones. Wow, this is a pretty ugly grouping, isn't it? Alright, so we need to be careful here. We need to try to make the minimum amount of groups possible. So it looks like 2 is pretty much as big as we can go. I'm going to start with this one, because this one has no choice but to be grouped with this one. And so I wouldn't have wanted to group the one in the upper right with this one here, because the other one has to be grouped with it. Where else does that happen? That looks like this one here has to group with this, and this one here, leaving this poor fellow all by themselves. And so there may have been other ways to do this, but the goal is you need to keep it to the minimum number of groups. Alright, so let's start A, B, C, and D. Alright, so starting with this one, it is inside of A, it crosses B, it is outside of C, and it is outside of D. This one here we'll do next. Inside of A, inside of B, crosses C, and inside of D. We'll do this one here. Crosses A, outside of B, inside of C, outside of D. Do this one. Outside of A, inside of B, and inside of C, it crosses D. And then finally, this one up here is the only one I didn't do, right? Are you guys watching? Is that the only one I didn't do? Outside of A, outside of B, outside of C, and inside of D. There we go. Alright. Man, how many of these did I give you? So many. Alright, let's do this one. So 0, 0, 1, 0, 0, 0, 1, 0. Is this the one I just did? No. 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, nope, 0, 1, 1, 0, so 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, so where's 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, that's this one, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and all ones. Oh, this one's nicer. What do you think? I think it's nicer. So we got a group of 8. And we've got a group of 8. A range, B, C, and D. Alright, so we'll do the yellow group first. So crosses A, crosses B, entirely inside of C, and it crosses D. And then the red group is entirely inside of A, crosses B, crosses C, and crosses D. And that's it. Alright, this one. So, something we need to know. On the left, remember, we have our inputs. So inputs tell you how big the K-map is, right? We need 16 blocks because this is 4 inputs. On the right, tells you how many. So how many do we need? And actually, I just copied and pasted this from the others. So let's do alarm 1 first. This is going to be alarm 1. Remember, we have EN and RS as our inputs here. We have D0 and D1 as our inputs over there. Remember, not everything is named A, B, C, and D. So if we look here, the first one we have in alarm 1 is 1001. So 1001, 1010, 1010, 1011, 1011, 1101, 1101, and all ones. So that looks like it. So we gotta be careful here now. This is our EN range. This is our RS. So notice it's the same places, we just have different names for them. This is the D0, and this is the D1. My groups, I've got a group of 4, and I've got a group of 2. We'll do the blue one first. It's entirely inside of EN. It crosses RS, it crosses D0, and it's entirely inside of D1. Alright, next group. In red we have entirely inside of EN. It is entirely outside of RS. It's entirely inside of D0, and it crosses D1. So that's our first group. Second group, alarm 2 down here. We have 0001, 0001, 0010, 0011, 0101, 0111, 1001, so 1001, 1010, 1011, 1101, and all ones. Alright, so for this one, we've got a group here. And we've got a group of 4 here. That looks like everything. So A, nope, not A, not A. This is EN, RS, D0, and D1. It's got to be in the same order too. Alright, so this is EN. This here is RS. This is D0. And this is D1. So we'll do the blue group first. Entirely, it crosses EN, entirely outside of RS. It's entirely inside of D0, and it crosses D1. And then for the red, crosses EN, crosses RS, crosses D0, and it is inside of D1. There we go. Alright, so these are the ones with the don't cares. So remember, this tells us just which values. So we have a 1 at 0, 0, 0. We have a 1 at 0, 0, 1. We have a 1 at 4, which is 1, 0, 0. We have 1 at 5, which is 1, 0, 1. And then we have don't care. So we have a don't care at 3. Wait, 1, 2, 3, 4. I only filled out 4 and there's 5 there. 0, 0. 0, 0, 1. 0, 1, 0. I don't need one there. Alright. Then we've got our don't care. So 3, we've got 1 at 6, which is 1, 1, 0, and we've got 1 at 7, which is 1, 1, 1. Ah, look at this trick case. What's the biggest group you can make? Well, we can group them all together. Look at that. This is like the absolute best case possible. Why is this the best case possible? Notice, this equation, it equals 1. We don't need to build a circuit. Just tie it to a battery. Make it 5 volts. It can always be true. Tricky, huh? But that's like the best case. Alright, let's try this one. So, there is a 1 at 0, 0, 0. There is a 1 at 6. So 6 is 0, 1, 1, 0. Where's that at? Here. There is a 1 at 8, which is 1, 0, 0, 0. There is a 1 at 13. What's 13? 13 is this, I think. Right? 1, 2, 4, 8, 12, 13. Yep. So 1, 1, 0, 1. There is a 1 at 14, which would be 1, 1, 1, 0. Where's that at? That's right here. And now we have our x's. There's an x at 2, 0, 0, 1, 0. Boom, don't care. There's an x at 0, 1, 0, 0. I also don't care. And then finally, there is 1 at 10. What's 10? Anybody remember 10? 1, 0, 1, 0. It kind of looks like 10, doesn't it? 1, 0, 1, 0. Boom. Oop, nope, x. Alright, so now we have to group them. Remember that we only care about the ones. We don't have to group the x's. Only if it helps. So it definitely helps here. So there's my first group. Pick a different color. So look at this one. I could just group these two together, but I can actually do better than that. I'm going to group these two here with these two over here. So I've got like a postage stamp thing. 4 corners. And then last but not least, we've got just this guy all by himself. Alright, so let's set up our equation. We've got the A, we've got the B, we've got the C, and we've got the D. So starting with the blue one, it crosses A, it crosses B, it's entirely inside of C, and it's entirely outside of D. So that's our blue group. Now let's do the red group. It crosses A, half in A, half out of A. It's entirely outside of B, so B not. It's half in, these over here are in, these are out of C, so it crosses C, and it's entirely outside of the D range. And then for our last one, it's all by itself, not much we can do. It is inside of A, it is inside of B, it is outside of C, and it is inside of D. Boom. We're done with that one. 4 corners are tricky though, huh? Alright, and the last one. Alright, so again we've got a 1 at 0, 0, 0, 1, at 0, 0, 1, 1, at 0, 1, 0, 1, at 0, 1, 1, 1, at 1, 0, 0, 1, and at all ones. 15 is all ones. And we've got some don't cares. We've got a don't care at 0, 1, 0, 0. That's 4. Got one at 0, 1, 1, 0. Where's that at? Anybody see it? Oh yeah, there it is. We've got one at 12. Didn't I just do 12? 1, 1, 0, 0, right? I shouldn't guess. I'm going to make a mistake and have to do this again. You watch. And 13, 1, 1, 0, 1. Boom. Alright, what type of groups can we make here, guys? Well, what I like to do is I like to start with the biggest I can make first. So the biggest I'm going to make first is this guy sitting out here. We have really no choice, right? The only way we're going to make him big is if we connect him with that group of 4. So that gets that out of the way right away. Next, I got to group these ones. Going to take them here. And last but not least, I've got another group of 4 here. So notice I'm using the X because it helps. I'm overlapping because it helps. And I'm going to ignore this X, and this X because they don't help. Go ahead and set up our ranges one last time. This is the last problem, y'all. C and D. Starting with the blue group, it is entirely outside of A. It crosses B, half in B, half out of B. It's half in, half out of C, but the whole thing is in D, so we write D. What do we got now? Red group. Red group. Where's red? Red group. Alright, crosses half in, half out of A, half in, half out of B. It is entirely outside of C, and it is entirely inside of D. And last one, last group of the whole homework. We have it entirely, it crosses A, half in, half A, looking at the white group. It is entirely inside of B, so we write a B. It is half in C, half out of C, but it is entirely inside of D. And we are done with this homework. Practice it. This is the most important thing all semester. It's going to be on your exam. You're going to have like 1 or 2 of them. You got to get it right because it's the one that counts for all the points. Contact me if you still don't understand it. This is really, really important. Talk to you later.